Okay, we have one more set of problems working with means, but now we have a paired difference in means. And they're paired because it is important that you work with the difference for each group individually. It may also be called a mean difference, so the mean of the differences. So the CAOS Comprehensive Assessment of Outcomes in Statistics exam is an online multiple choice test on concepts covered in a typical introductory statistics course. Students take one version before the start of the course and another version after the course ends. Before and after scores for a possible random sample of 10 students are shown in the table. We are interested in determining whether taking the course increases students' understanding as measured by this test. Why should we do a paired design rather than two separate groups? And that would be because we are interested in the increase in an individual's score and pairing the data reduces random variation. So the next question, we want to find the differences after minus before for all 10 students. So I left a row here for you to write the differences and then find the mean, standard deviation, and sample size for the differences. So we're taking after minus before, so 60 minus 43 is 17. 45 minus 40 is 5. 55 minus 48 is 7. 80 minus 65 is 15. 85 minus 60 is 25. 71 minus 48 is 23. 52 minus 43 is 9. 35 minus 38 is a negative 3. 54 minus 43 is 11. 55 minus 55 is 0. Now to find the mean and standard deviation, we're going to work with the last row of data, the differences, and enter them into the calculator. First, we need to clear out anything that happens to be there, and we're going to enter these values into L1. So we have 17, 5, 7, 15, 25, 23, 9, negative 3, 11, and 0. And yes, you do need to include the 0 because it is one of the data values. So we go to Stat, Calc, the first option of one var stats, make sure it's L1. So we have the mean of the differences is 10.9. The standard deviation of the differences, which is the SX, is 9.219. And the sample size of the differences, down here we're told N is 10. So now it says test to see if scores at the end of the course are higher on average than scores at the beginning of the course, and show all details. This means we're going to be working with the differences. So first one, we check conditions. And we're just going to assume normality. We could graph the differences and see if, do a dot plot, see if they were symmetric and if there were any outliers. Okay, so the null hypothesis is that the mean of the differences is equal to 0. That would mean that there's no difference. The alternative, we want to see if the scores at the end of the course are higher than the scores at the beginning. So we want the differences to be greater than 0, since we did the after minus the before. So mu of d is the mean increase in a student's score after taking an introductory statistics course. So our test statistics, what's nice about doing this is once we find the differences, we then only have one set of data with which we're working. So we do it as if we only have the one set of data. So it's mean, so it's T is statistic minus null over standard error. So it's x bar sub d minus mu sub d over s sub d divided by square root of n sub d. So our x bar sub d is 10.9, mu sub d is 0. Our s sub d is 9.219 divided by square root of 10, which gives us 10.9 divided by 2.915, which is 3.74. So our p-value, this is a right-tailed test. So it's TCDF, 3.74, 999, and 9, because our sample size is 10, so 10 minus 1 is 9. So we have second vars, TCDF, 3.74 is our lower limit, 999 is the upper, 9 is the degrees of freedom, and we get 0.00231. So then our conclusion. Since p-value is less than any reasonable significance level, we reject H sub 0 and conclude that there is strong evidence that on average scores increased after taking an introductory statistics course. Okay, so now we want what is the average increase on exam after taking the course. We want to compute and interpret a 95% confidence interval for the improvement in mean CAOS scores between before and after. So we want statistic plus or minus t-splat times standard error, which is x bar sub d plus or minus t-splat times s sub d over square root of n sub d. So our statistic is 10.9 t-splat inf t 0.95 plus 1 minus 0.95 over 2 and 9 degrees of freedom. So second vars inf t 0.95 plus 1 minus 0.95 divided by 2, 9 degrees of freedom. We have 2.262. So this is plus or minus 2.262 times 9.219 over square root of 10. So it's 10.9 plus or minus 2.262 times 2.915, which gives us 10.9 plus or minus 6.594, which gives us an interval of 4.306 to 17.494. So we are 95% confident that the mean increase for students on the CAOS exam after taking an introductory statistics class. Is between 4.306 and 17.494 over the test taken before the class. Actually, before the class started. Okay, so that's what you do if you have a matched pair. You find the differences between, for each individual student or case, and then you work with it as if it is a single set of data.